Welcome to Spring LIB.
Continuing on with electrochemistry here, where we're essentially just looking at the movements of electrons throughout our system. First thing we're doing is calculating an E cell value, where we have E cell is the E cathode. Reduction, subtract the E anode. Oxidation. E cell is equal to 0.446 volts, subtract 0.242 volts. E cell is equal to 0.204 volts. And so the relationship between the cell potential and the free energy change, delta G equals negative NF E cell, where N is 2 moles, F is 96385, E cell is 0.204, so we can solve for delta G by plugging in all our numbers, where delta G is negative 3.93 times 10 to the 4 joules. Following this, we can take a look at the general formula of the Nernst equation, that is E cell is equal to E naught, subtract 0.0591 divided by N multiplied by log Q, where Q is CRO 2 minus divided by Ag plus. So we have our products over our reactants. So we have moles, that is 2, so we plug in our value, so we now have E cell equals 0.242 because we calculated E naught, subtract 0.0591 divided by 2 of log Q. So we're given concentrations to plug in for CrO42 minus and Ag plus. So then we can solve for our E cell, that is 0.352 volts. And now to find the concentration, we can use the Nernst equation, where we have a lot of known information here. We're solving for the CrO42 minus. Concentration, that is our unknown. And so what we have is 0.504 volts equal to 0.242 volts, subtract 0.0591 divided by 2 log CrO42 minus divided by 1.00 mole per litre. We then solve this concentration that's missing, and that is equal to 1.36 times 10 to the minus 9 moles per litre. And lastly, we're calculating the solubility product of AgCrO4. So given the Nernst equation again, we have the equilibrium E cell equals 0. So what we have is 0.00 volts is equal to 0.242 volts, subtract 0.0592 volts divided by 2 log Ag plus squared CrO42 minus divided by Ag2 CrO4, where we solve for Ag plus squared CrO42 minus, that is equal to 10 to the 8.1895, and that is equal to 1.55 times 10 to the 8, and 1.55 times 10 to the 8 is the solubility product for Ag2CrO4.